Lesson 4 is looking at fitting a line to data. In the last couple of lessons, we've analyzed scatter plots and tables, unorganized data, organized data, and talked about what points represent. So we're now going to take that data. We're going to look at scatter plots as more of a whole. And the criteria is to use a model, and that's going to be a key word here, is we're using a model to predict values for data. And then we're also going to pick out outliers. Another key word, outliers. We're going to be able to say what that is and what that means on a scatter plot by the time you're done with this video. So we're going to start with a prediction. We're looking at a scatter plot that shows the weights and fuel efficiencies, which we talked about in the last lesson, of 20 different types of cars. If a car weighs 1,750 kilograms, would you expect its fuel efficiency to be closer to 22 or 28 miles per gallon? Explain your reasoning. Can I talk? Okay, so take some time, write down a response, and then be ready to listen to the conversation / me talking to myself. Okay, so didn't mean to skip forward, but when we look at this scatter plot, I would say we really expect it to be closer to 22 miles per gallon. If we take a look at where that falls on the graph, the 1750 is right here. And here's 22. And here's, let's see, where's 18? 18. So just based on those, oh, I'm sorry, not 18, 28. Just based on those 2 points, the 22 is just more in line with the trend data. So I would not really expect for that point to represent the 1,750. Okay, so now we go to the shine bright. When you look at this picture of the diamonds, which diamond do you think has the highest price? And I think most of us would probably predict that the bigger one has the highest price. But to give you some background knowledge, the size of a diamond is one thing that its price is based on. The size is commonly measured in carats, which is a measure of weight. And 1 carat is actually equal to 200 milligrams. Now, on the next picture I'm going to show you, now which diamond do you think has the higher price? Well, these diamonds are the same size, but they are not the same price. Price is not based on size, but it's also based on how many flaws are inside the stone. So if you look really closely at the stone on the left, you could see there's kind of like some, like, I don't even know how you would describe it, but it's not as clear as the stone on the right. So again, it has a lot to do with the clarity of the stone and not just the size of the stone. So you're going to look at some data for the prices of diamonds of different sizes, and that's what's going to be in this next activity on page 24. So you're going to have a table, which is going to show the weight in carats, the actual price, the predicted price. And you're going to have to use mathematics to analyze these real-world situations, identifying variables in a situation, and describing their relationship mathematically. And this process is actually called modeling. And we'll talk a little bit more about that and where you're going to see this in the activity. And the mathematical description would be just a model. So sometimes you made assumptions about the situation or you ignored some features so that the model would be simpler. So all these components are important here. I'm going to scroll so we can just highlight some of these key pieces together before you work. But the scatter plot shows the prices and weights of 20 diamonds together with this graph of, gives you an equation, y equals 5,520x minus 1,091. That's part of that scatter plot. The function described by that equation, going to highlight that again, then I'm going to use a different color to really emphasize this, is a model of that relationship between a diamond's weight and its price. The model actually predicts the price of a diamond from its weight. These predicted prices are shown in the third column of the table. So just to emphasize, we have the weight in carats, the predicted price, which is coming from our model, which is right here. This is the model. And then you have the actual price. I'll use blue here. And that's what that table is representing. So let's take some time to use the table, use the scatter plot, use the model. To go ahead, you have 5 questions to kind of work through, and then I'll talk through the components to make sense of everything. So this is where you're going to want to pause, do some work on your own, and then be ready to listen. Okay, so starting with the first question, about 2 diamonds that both weigh 1.5 carats have different prices. What are their prices and how can you see this in the table? How do you see this in the graph? Okay, so let's go to that 1.5. Here's where we see it in the table. I'm going to grab a different color, purple. Okay, here's where we see the 1.5 in the table. And let's go to the graph. Here's where we see it in the graph, the 1.5. And their prices that we see are the 7,474. And I think me boxing those is misleading, so I'm going to unbox that actually. Let me do this. Okay, so let's be more specific where I see them. So the 1.5 is the 7,474, and the predicted price, because that's really what we're looking at. Oh no, I was right. Never mind. I'm lying. Just kidding. I am going to box it again. Okay. We're good. I'm ahead of myself. Okay, so now the model predicts that when the weight is 1.5 carats, the price is going to be the $7,189. How can you see this in the graph? This is where I was ahead of myself. Sorry, you guys. Okay, so now we're using that line to help us with that prediction piece. So on the graph, we see that here. It's where it falls on the line. But how do we see this in the equation? Well, we take that information, the 1.5 carats, and we're going to use it in the equation. So y is equal to 5,520 times the 1.5, because that represents the carats, minus the 1,091. And when we evaluate that, we actually end up with 7,189, which, going back to the table, is seen right here. So again, actual price are the points on the scatter plot. 7,189 comes from that line. The prediction line predicts the price, the model. Okay, so then question 3 says one of the diamonds weighs 1.9 carats. What does the model predict for its price? How does that compare to the actual price? So this, you're going to want to actually think about using the equation here. And the 1.9, because when you look, oh, it is in there actually. It is in the table. Sorry about that. Here's the 1.9 in the table. Here's that predicted price. How does that compare to the actual price, which is here? So we would say that the actual price is $144 greater than the prediction. And then if we look on the graph, we'll just kind of analyze where that would fall. You could kind of see, I'm assuming it's probably this point right here, because it's just a little bit more. The actual price is a little bit more. That's why it falls above the line. Question 4 says, find a diamond for which the model makes a very good prediction of the actual price. Let me grab a highlighter here, and I will use pink. So looking at here, I would say that this point right here would represent a very good prediction for the actual price because the point is on the line. And I believe that that point is probably the 1.2. And notice the prediction. Here's the actual price. Here's the predicted price. They're very, very close. They're off by $10. So the model did a really good job with that prediction there. But then when we go to question 5, find a diamond for which the model's prediction is not very close. How do we see that in the table? How do we see that in the graph? Well, I'm going to go to the graph first, and I believe that the point that which we actually circled earlier, this guy here, let me use a different color, green. This guy here, I would say, is probably not a good, the line doesn't model a good prediction for that point because it's further away from the line. And if we go back to this from earlier, you can see it because of those numbers here. The prediction was 7,189, but the actual price was 5,904. So just some summary questions. What does the point of the scatter plot represent? We know that the scatter plot gives us the weight in carats in comparison to the price in dollars. What does the line represent? The line, which is part of our success criteria, talking about modeling, it's a linear model of the situation, which helps us make predictions. What does it mean when a point is close to the line versus far from the line, which is what we've seen in those last 2 questions. When it's closer to the line, it's very close to that predictor that we have, but when it's far away from the line, it's not in line with that prediction. How can you use the graph to predict the price of a diamond that weighs 1.1 carats? And then how can you use the equation? Well, if we use the graph, we're just going to look on the graph to see where is 1.1 fall. And 1.1 is close to here, I would say. And we would look to see where at on that predictor line it would fall. And we would maybe estimate that its price would be $5,000. If we use the equation, we would substitute that into that equation of 5,520 times the 1.1 carats minus that 1,091. And then we would get an actual value, which is also a predictor. So 2 different ways to kind of analyze that. Okay, so the last piece that we're looking at for this lesson is the agony of feet. What do you notice and what do you wonder about these feet here? Well, what I will tell you is that foot A is a size 8, foot B is a size 8, and foot C is a size 8. Even though they're all the same size, they wouldn't necessarily find the same shoe equally or comfortably because of the varying width. So size A has a much larger width than foot A. So a scatter plot has been created for you to analyze these feet dimensions. Estimate the lengths of the longest foot and the shortest foot to just start with. So in thinking about an estimate, when I'm looking at the lengths of these feet, of the feet that we're talking about, my longest foot is obviously going to be the one with the biggest value, which I see is here. So I'm going to estimate that to be close to about 30 centimeters. A little bit more. And then the shortest foot, I'm going to estimate to be, let's see, here's going to be my shortest feet, close to probably 21 centimeters. And then we're going to do the same thing in estimating the width. So I'm looking at the widest foot and the least widest foot, the narrowest foot. So again, that same point kind of falls like right around here. So it's a little under 12. So I might say it's close to maybe 11.9 centimeters. And then my narrowest foot, it's going to, let's see, fall somewhere around here again. And that's probably going to be maybe 9.3 centimeters. So we take that same scatter plot and we now put a linear model in that scatter plot to help us make predictions. So let's circle the data point that seems kind of weird. I'm going to grab a highlighter to do that. But I think this point kind of seems strange. Let me get a different highlighter. There we go. That point seems kind of strange. That point, I would say, is about 24 and a half, 7 and a half. We actually would call this point an outlier. So if you want to write that down next to it, you can. So here's some information about outliers. An outlier is a point that is separated from the rest of the data, which you can see there. Sometimes data sets have outliers. Sometimes that's because there really is a data point that is very different than the others. If you listened to my video for lesson 2, you saw that one of the data points didn't really seem right, and I guess that maybe a student entered it in incorrectly. So sometimes there can be errors. Sometimes it's because there's an error in entering the data versus collecting it. But when there's outliers, you have to kind of make judgment about whether or not to include it in the analysis or not. So because it does kind of affect your data, especially when there is just one point that doesn't seem to make sense. So what kind of model for a data set did we investigate today? And we investigated using a linear model. You see that with the line that goes through our data points. What does this kind of model help us do? And it really helps us see the trend in the data more clearly and make predictions. What does it mean when a data point is closer to the vertical direction to the line that represents a linear model versus farther? Well, when the data point is closer to the vertical direction of the line, it represents data that fits the prediction well. But when the point is farther from the line, the data does not fit that prediction well. So in your own words, how can you identify an outlier from a scatter plot? Reflect on that on your own. Okay, so you can read through that summary, but we pretty much summarized together. But the criteria that you should have mastered is using a model to predict values for data, and then can you pick out outliers on a scatter plot? In hopes that you feel confident about your work, then your practice plot problems, for me, Mrs. Williams, would be page 29 to 30, numbers 1 and 2. Actually, there's only 2 problems, so it shouldn't matter.